Hi, I'm Miss Hearn. Let's get started. This is a radical equation where we have two square roots in it. Now we solved the last radical equation by squaring both sides. That got rid of the radical. We cannot just square this left side right now the way that it is and get rid of a radical. If we square it, remember what happens when you square a plus b? You get a squared and you get b squared, but you also get twice their product in the middle, 2ab. So if the a and the b are these two big radicals here, you're going to end up with a middle term that has a really big ugly radical in it. So you're going to move one of the radicals over to the other side, and we're going to square it and get rid of one radical at a time. So I'm going to add square root of negative x plus 7 over here. So we're going to have the square root of 6 minus 2x equals negative 2 plus the square root of negative x plus 7. Now we're going to square both sides to get rid of at least one of these radicals. The radical on the left goes away, leaving just 6 minus 2x underneath, but on the right, keep in mind that when you square a binomial, it follows this pattern, right? It FOILs out. The common error that I see is people think they can just square each part and be done. You can't do that, unfortunately. So what we're going to do instead is we're going to think of FOILing that out. I'm going to write it off to the side. Okay, how would we FOIL that out? We'd have first times first would be positive 4. Outer times outer would be negative 2 square root negative x plus 7. Inner times inner would also be negative 2 square root negative x plus 7. And last times last would be what? What happens when you multiply a square root times itself? Yes, good. The square root goes away. We just have negative x plus 7. Okay, or another way of thinking about this is you get the first term squared, 4. You get the second term squared, negative x plus 7, and you get twice their product in the middle. 2 times negative 2 is negative 4 square roots of negative x plus 7. Okay, so I'm going to put that into the equation over here. So we've made some progress, but these problems are long because we were able to only get rid of one of the radicals, and now we need to isolate the other remaining radical and do the same thing over again. First, I'm going to combine the 4 and the 7. So we have 6 minus 2x equals 11 minus 4 square roots of negative x plus 7. Common error, you cannot subtract 11 minus 4. This 4 is part of this radical term. These two are not like terms. You cannot subtract them. All right, so what are we going to do to get the radical term by itself? Yeah, we're going to add x to the other side, and we're going to subtract 11, right? So what are we going to have? Negative 5 minus x equals negative 4 square roots of negative x plus 7. Now, a lot of times people think they need to get the radical completely by itself, but that's not actually necessary, and that will cause fractions. So you don't want to divide by 4. However, since our next step is going to be to square both sides, and that can get confusing with all these negatives, I probably would divide both sides by negative 1 just to kind of make it a little less confusing for myself. You don't have to, but that would give us 5 plus x equals positive 4 square root negative x plus 7. Now we square both sides again to get rid of the second radical. So on the left, we have a binomial being squared. So you can either FOIL it out, or you can follow the pattern. You're going to have the first term squared, last term squared, and twice their product in the middle. That's what I'm going to do. 5 squared is 25. X squared is x squared. And we want twice their product. Their product is 5x, so 10x is going to be in the middle. There's even a little rhyme about it. Square the first, square the last, multiply together, and double up fast. So then that's going to be now on the right. Since these are being multiplied, they're one term, you can just square each part. You don't have to go through that whole FOILing thing. So 4 squared is going to be 16. And when you square the square root, you're going to get negative x plus 7. The radical goes away. All right, this is major progress here because notice we no longer have any radicals. We actually have a quadratic. We just need to get it in standard form and solve. So this is going to be 25 plus 10x plus x squared. I'm going to distribute through the parentheses. Negative 16x plus 112. Okay, I'm going to get it in standard form. So I'm going to move everything to the left, keeping the x squared term. I have a 10x and I'm adding 16x, so plus 26x. I have a 25 and I'm subtracting 112. Negative 87 equals 0. Now we have a quadratic equation in standard form. Plug into the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. But in this case, a is 1, b is 26, and c is negative 87. So we have x equals negative 26 plus or minus the square root of 26 squared minus 4 times 1 times negative 87, all over 2 times 1. So x equals negative 26 plus or minus. Okay, so we're going to have negative 26 plus 32 over 2, or negative 26 minus 32 over 2. All right, this is going to be 6 over 2, which is 3. And this one's going to be negative 58 over 2, which is negative 29. Okay, we have to check. So if x is equal to 3, we get the square root of 6 minus 2 times 3. Minus the square root of negative 3 plus 7. This is the same as the square root of 6 minus 6 is 0, minus the square root of negative 3 plus 7 is 4, which is in fact equal to negative 2. So this is a solution. And let's check the other one. 6 minus 2 times negative 29 is the same as 6 plus 58. So that's the square root of 64 minus the square root of, it's going to be positive 29 plus 7. So that's going to be the square root of 36. So we have actually 8 minus 6, which is positive 2, which is not what we were looking for. So that was an extraneous solution. The only solution to the equation is x equals 3.
I hope you found this video useful. If you did, please remember to like it.